Welcome to Omni-Faceting Design Concepts. One of the disadvantages of Western-style faceting is that it often sacrifices weight in favor of optics. The rough may be trilliant-shaped, but deeper than the trilliant design, and you may not want to invest the time required to cut a deep Meetpoint design like a London shield. What if you could easily alter your favorite designs to preserve an average of 30% more weight, while deepening color and potentially enhancing optics? What if the altered design would be just as fast and possibly even easier to cut than the original? I call this trick OMNI-fication. It's a way to reverse engineer the girdle plan of a design you like into an Omni-type pavilion that fits under the crown of your choice. This sounds more complicated than it is. As an homage to the originator of the Barrian concept, let's start with a classic Watermeyer trilliant design. The first step in this process is to delete the pavilion. We want to build a new pavilion that will save as much as 30% more weight while giving strong optical performance, and we don't want to have to redesign the crown. We first need to plan the Omni guide faces, which will be arranged in a conical pattern, all cut on the same angle and height setting. But because we will have to adapt those guide faces to the shape of the girdle, we want to keep them off the corners. That exclude indexes too close to the indexes 16, 48, and 80. I'll select a point on the edge of the girdle, here, and we'll try the first set on an index of 12 at an angle of 43 degrees to make the temporary culet. Let's zoom in for a close look at how the second set of guide faces will drop in. We want the edge of the second guide faces to coincide with the girdle junction, here. We're reverse engineering the girdle profile, so when the stone is cut in practice, the guide faces will locate the girdle faces for a perfect fit into the crown. We'll try an index of 5 for the second set of guide faces. Remember that we want to cut to the same depth, so we will meet the point here. And we want to use the same angle, 43. That guide face falls shy of the junction we want to calibrate, here. So we'll try again, this time at an index of 7, still on an angle of 43, still meeting the point. That one's a little over. Goldilocks says to try again on an index of 6, and that one is just about dead on. This is all we need to know to build the new pavilion geometry. We'll start a new project to show how this works from the beginning. Start by cutting an angle of 43 on an index of 12, and we get a point. Continue cutting to that point on an index of 6 without changing any machine settings. That's the CAM Omni setup. We change to 90 degrees to cut the girdle faces using the typical trilliant indexes of 6 and 2, so girdles meet the guide faces. That looks like this. Now we have a perfect, classic trillion shape, but the girdle needs to be leveled using adapter faces, just like any other Barrian would. When we select an angle for our first adapter faces, we want it to be high enough to prevent cutting into the critical area of the optical cone, and we want it to be something a jeweler won't curse us for while he's trying to set the stone. Something between 60 and 70 degrees is usually workable. I'm going to do this one at 64 degrees. Remember that adapter faces cut on the same index as the girdle they're leveling. We're going to level this girdle first. The index is 6. And meet at the corners where guide face meets girdle, here. That levels half the girdle faces. Now we'll level the rest using another set of adapter faces on the same index as the next girdle, 2. We want this adapter face to meet the junction of the guide faces, here, and we want it to meet the girdle we've already leveled, here. We'll round the angle to 66 and cut it. Now for some pavilion mains. The guide faces are on indexes of 6 and of 12. Index 9 is halfway between, so we'll try that. We want to meet the junction of guide faces and adapter faces, here. Let's cut this set of mains on an angle of 41 degrees. That makes a nice star shape. We'll transfer the stone and cut in the crown exactly as it was. In some cases, the Omni guides don't fit the girdle precisely, and you'll have to do minor adjustments to the crown to make everything meet up nicely. In this case, we've preserved the girdle geometry perfectly, so the crown fits exactly. Now let's evaluate this design. The original ray traces at cosine brightness of 66.7, while the new design shows a figure of 69.6. Pretty good. The volume of the original was 171, while the volume of the new design is 222. That's about a 30% increase in weight. As you can see in this overlay, the weight is in the expanded and deepened pavilion, which will also enhance color saturation. This juicy 6.38 carat Nigerian spessartite garnet was the motivation for the Omnified trillion. The rough weighed 20.5 carats. The Omnified design helped me yield over 31% and a good 2 carats more than the simple trillion design could have delivered from the same rough. The Omni strategy allowed us to skip some steps from the original cam strategy. So by making only one more angle and height adjustment than the original design required, and by polishing just 12 more faces, I probably added around $1,000 to the wholesale value of this gem. For more information about the Omni design process, stay tuned to the Gemstone Artist channel on YouTube, or attend one of our faceting camps. Learn more or download free copies of these and other gem diagrams from the website at www.gemstoneartist.com.